All right, so you're getting ready for the AWS Certified AI Practitioner exam. Well, we've got your slides and study guide right here, ready to pull out the most important stuff for, to really help you succeed.
And I'm excited to help you master all this material, as both someone who's, taught this stuff and someone who's always learning myself.
Nice.
Yeah,
So let's just dive right in. Can you give us a quick overview of what this exam actually covers?
for sure. The AWS Certified AI Practitioner exam goes deep into 5 main areas. We'll start with the basics of AI and ML, then get into the world of generative AI. After that, we'll look at how foundational models are used. That's where it gets really interesting. Then we'll touch on responsible AI and finish up with security, compliance, and governance for AI solutions.
5 areas. Wow. Okay, we've got our work cut out for us. So let's start breaking it down one by one, beginning with the domain 1. Fundamentals of AI and ML. What are some of the core concepts they test you on here?
This domain is all about the building blocks of AI and ML. You need to know how to define AI and its different uses, like, self-driving cars or medical diagnoses. The exam also wants to see if you understand intelligent document processing, like imagine being able to automatically pull key data from like invoices or contracts. That's AI in action.
Okay, that makes sense. So document processing is one way we can use AI. What about machine learning?
Machine learning is what powers a lot of AI applications. It's all about systems that learn from data to do their job better. Think of it like a chef who keeps tweaking their recipes based on customer feedback. That's machine learning.
I like that analogy. So we've got AI as the big picture, and then machine learning is a specific technique within AI. What else do we need to know about machine learning?
You got to understand the different types of machine learning. Supervised learning uses labeled data. It's kind of like having a teacher guiding you along. Imagine you're trying to predict house prices based on things like size and location. That's supervised learning, on the other hand. Unsupervised learning is about finding hidden patterns in data that's not labeled. Think about grouping customers based on what they buy. That's unsupervised learning.
Interesting. So supervised learning has those input-output pairs, and unsupervised learning uses unlabeled data to spot those patterns. What about the steps involved in actually building a machine learning model?
That's where the machine learning development lifecycle comes in. It's a process that repeats with these main phases: collecting data, getting the data ready, training the model, evaluating how well it works, deploying the model, and then keeping an eye on it. It's all about continuous improvement. You're always refining and tweaking the model to get the best performance.
So it's not just build it and forget it. There's that ongoing evaluation, and improvement makes sense now. Where does AWS fit into all of this?
AWS gives you this powerful platform and a whole set of tools to build, train, and deploy your AML solutions. 2 services you really want to know are Amazon SageMaker, a comprehensive ML platform, and Amazon Bedrock, which gives you access to those powerful foundation models for generative AI.
Okay, so AWS gives us the tools to make these AI and ML solutions a reality. Now let's jump to domain 2, generative AI. What makes this area so exciting?
Generative AI takes us beyond just analyzing data. Now we can create new content, anything from text and images to music and even code. Think about generating those realistic product descriptions or composing music in different styles. The possibilities are pretty much endless.
Wow, that's amazing. What's the technology behind all of this?
At the heart of generative AI, you've got large language models, or LLMs. These models are trained on huge amounts of data, which lets them understand and generate language just like us humans.
So like language wizards, what are the benefits of using generative AI in business?
Generative AI is incredibly adaptable. It can handle a wide range of tasks across many different areas. It's also super responsive. It generates content in real time, and it simplifies complex tasks, which makes it easier for people to use.
Powerful, fast, and easy to use sounds great. Are there any downsides we should be aware of?
Well, like with any powerful technology, we got to use generative AI responsibly. One potential problem is when it generates incorrect or misleading information. We call those hallucinations.
Right, so we can't just blindly trust everything the AI produces.
Exactly. You got to be a little skeptical and use your critical thinking skills when you see AI outputs. Now, let's talk about some specific AWS services that help us tap into the power of generative AI. Amazon Bedrock is your go-to service for building and using those generative AI applications. It gives you access to a bunch of really powerful foundation models and lets you experiment, customize, and even create these autonomous AI agents.
Wait, AI agents, that sounds pretty futuristic.
It is. These agents are like independent systems that can handle tasks, like summarizing documents, translating languages, even writing code and creating art. It all depends on how you train and set them up.
It's amazing how quickly this technology is developing. So what should we consider when we're choosing and evaluating these models?
That's a great question. First, think about the cost. Different models have different price tags, so you got to balance your budget with the level of performance you need. Then think about the type of data you're working with. Some models are great with text, others are better with images or audio.
So the right tool for the right job. What else?
Latency is important too, especially if you need real-time responses. And if you're working with a global audience, make sure your chosen model can handle multiple languages.
So it's all about picking the most suitable model, not just the most powerful one. Once we've got a model, how do we customize it to fit our specific needs?
Customization is key. You might fine-tune the model with your own data or adjust some settings to optimize its performance. It's like tailoring a suit, getting that perfect fit.
I like that analogy coming back full circle. And how about RAG, that technique we talked about earlier? Where does that fit in?
Retrieval-Augmented Generation, or RAG, is a powerful way to customize your models. It lets them pull information from external data sources. It's like giving them a research library to consult this and make sure their responses are relevant and up to date.
So RAG basically expands the model's knowledge base. That's pretty impressive.
Yeah.
Are there any limitations we should be aware of when using these models?
Of course, one thing to consider is the limit on the length of inputs and outputs. Some models can only handle a certain number of tokens, which affects how long your prompts and responses can be.
That makes sense. We need to be mindful of those limits when we're designing applications.
Absolutely. Now let's dig a little deeper into ARG and how it impacts things. One of its biggest strengths is that it addresses a weakness of those traditional generative models.
What weakness is that?
Traditional models are stuck with the data they were trained on, their knowledge is static. But RAI lets them access the latest information because it can incorporate those external data sources, so it makes sure the responses are timely and relevant.
So our Ray is like a system that never stops learning, always updating what it knows.
Exactly. Think about what you could do with that. A customer support chatbot that uses R could access a company's entire knowledge base to give accurate answers. Financial analysts could use it to analyze market trends and give investment advice.
Those are some really cool examples. Our Rise sounds like it could be a game changer in a lot of industries.
It really does. And the key service for implementing R on AWS is, you guessed it, Amazon Bedrock.
Bedrock, again, it's the MVP. How does it help us build our RAG applications?
Bedrock simplifies the whole process of bringing in those external data sources, so it makes building and deploying your RAG systems much easier. It's like the foundation you build your RAG on.
Makes sense. So we've got Bedrock giving us access to the models and helping us integrate data for ARG. What else do we need to know to use RA effectively?
Vector databases are essential for our gadgets. These special databases are designed to store and search embeddings, which are like numerical representations of data points.
Embeddings. Can you remind me what those are?
Embeddings capture the meaning of data, whether it's text images or audio. They let us compare and find similarities between different data points.
So vector databases are crucial for applications that rely on understanding the meaning of data and finding similarities between different pieces of information. Does AWS have any services for storing embeddings in these databases?
For sure, there are a few AWS services that can do this. Amazon OpenSearch Service, which is a fully managed search, and Analytics Service has built-in support for vector search.
It's like a search engine that's been supercharged with meaning and context.
You got it. Amazon Aurora, a cloud-native relational database, can also handle this. It supports the PG Vector extension, which lets you store and search embeddings right within the database.
So we can combine the power of relational databases with the flexibility of vector search.
Precisely. And if you're working with graph data, Amazon Neptune. A purpose-built graph database can store and search embeddings efficiently, which lets you use the power of graph relationships in your AI applications.
It's incredible how AWS offers such specialized services for working with embeddings and vector databases.
It's all about giving you the right tools for any AI task. Now, we've talked a lot about customizing these foundational models, but customization can be resource intensive.
Yeah.
Let's take a minute to think about how much these different approaches cost.
That's a great point. Managing costs is super important for any project. Can you break that down for us?
Let's start with pre-training. That's where you build a foundation model from scratch using massive data sets. It gives you complete control, but it's also the most expensive option.
So pre-training is like building a custom-designed house. You're in control, but it's going to cost you.
Exactly. You need a ton of computing power, data storage, and expertise. Then we have fine-tuning, which is where you take a pre-trained model and adapt it to a specific task. It's more cost-effective because you're using an existing model and only need to train it on a smaller data set.
It's like renovating an existing house, cheaper than building a new one, but you can still make it your own.
Exactly. Then there's in-context learning, where you give a pre-trained model some examples to guide its behavior. This is the cheapest option because you don't need to train the model, but it's not as flexible because you're limited to what the model already knows how to do.
So in-context learning is like redecorating a house. You can make some changes, but you're stuck with the basic structure.
Another great analogy. And finally, we've got RAG, which cost-wise falls somewhere in the middle. It's more expensive than in-context learning, but cheaper than fine-tuning.
ROG is like adding an extension to your house. You get more space and functionality, but it costs more than just redecorating. I love these analogies. It's clear that there's no one-size-fits-all when it comes to customization.
Exactly. You got to pick the approach that balances cost, performance, and flexibility for your specific project.
That's great advice. We've covered a lot of ground in Domain 3 applications of foundational models. Ready to move on to Domain 4 responsible AI.
Let's do it. Welcome back. Ready to dive into Domain 3, applications of foundational models.
Absolutely. We've got a good foundation now. Let's see these models in action.
All right, so to understand how these models work, we got to start with the concept of tokens. They're like the building blocks of language models, the smallest unit of text a model can understand, like words, punctuation, even parts of words.
So it's like breaking down language into its most basic components.
Exactly. And then there's chunking. That's where you divide the text into meaningful phrases. This helps the models get the context and relationships between words, kind of like how we group words together to understand stuff.
Right, context is super important for understanding.
Absolutely. Now let's talk about large language models, or LLMs. These are the powerhouses behind a lot of AI applications. They use a transformer architecture, which allows them to process information really efficiently in parallel.
We've heard about transformers before. What makes them so special?
Transformers are great at understanding those long-range dependencies in language. Like a really complex sentence where the subject and verb are far apart, transformers can still get the meaning because they're analyzing how all the words relate to each other, not just the ones right next to each other.
So they're like linguistic detectives piecing together clues from across the sentence.
Yeah, famous LLMs like BERT and GPT are based on this transformer architecture.
Oh, yeah. BERT and GPT. I feel like those are everywhere these days.
They really are. They're changing how we interact with language and information. And then we have foundation models, or FMs. These are even more powerful than LLMs. They're trained on massive data sets and can handle a wider range of tasks.
So FMs are like the ultimate AI multitaskers.
Exactly. Highly versatile. Think of them like the Swiss Army knives of AI. And as we talked about before, generative AI, which is powered by these foundational models, offers some amazing benefits.
Let's recap those benefits.
Generative AI can adapt to all sorts of tasks across different domains. It's super responsive, generating content in real time, and it makes those complex AI tasks easier for people to use.
Sounds like generative AI is breaking down barriers and opening up all these new possibilities.
It really is, but it's important to remember those potential pitfalls we discussed earlier, those hallucinations, where the AI generates incorrect or misleading information.
Right, we can't just take everything the AI says as gospel.
Exactly. Always think critically and don't be afraid to question the AI's output. Now, let's dive into some AWS services that are specifically designed for developing generative AI applications.
Sounds good. I'm ready to get practical.
One service you'll want to know is Amazon SageMaker Jumpstart. It's like a hub for ML with pre-trained models for all sorts of tasks like image generation and text summarization.
So it's like a library of ready-to-use AI models.
Exactly. And SageMaker Jumpstart also ensures secure data management, which is super important when you're dealing with sensitive information.
Security and privacy are always top of mind when it comes to AI. What other tools does AWS offer in this area?
Amazon Bedrock, which we mentioned earlier, is another key service. It provides a secure and scalable environment for building and deploying those generative AI applications.
Remind me how Bedrock works.
Bedrock gives you access to those powerful foundation models from leading AI companies. You can play around with different prompts, customize the output, and even create AI agents.
Hold on, AI agents, that sounds straight out of science fiction. What can they do?
These agents are autonomous systems that can do things like summarize documents, translate languages, even write code and create artwork. It all depends on how you train and configure them.
It's amazing how this technology is evolving. What should we keep in mind when we're choosing and evaluating these models?
Great question. First off, consider the cost. Different models come with different price tags, so you need to balance your budget with your performance needs. Also think about the modality of your data. Some models are better with text, while others excel with images or audio.
So choose the right tool for the job. What else?
Latency is important, especially for applications that need those real-time responses. And if you're working with the global audience, you got to make sure your model supports multiple languages.
So it's not just about picking the most powerful model, but the one that's the best fit for the job. Once we've picked our model, how do we customize it to our specific needs?
Customization is key.
Yeah.
You can fine-tune the model using your own data or adjust the parameters to get the best performance, like tailoring that suit we talked about, getting that perfect fit.
I see the analogy coming full circle. Now, what about RAG? Where does that technique come into play?
Yeah. Retrieval-Augmented Generation, or RAGs, is a powerful way to customize these models. It lets them access and incorporate information from those external data sources. It's like giving them a research library to pull from. This helps make sure the responses are relevant and up to date.
So ARGI basically gives the model a knowledge boost that's pretty impressive.
Hmm.
Are there any limitations we should be aware of when we're working with these models?
Absolutely. One key thing is the limit on the length of inputs and outputs. Some models have a cap on the number of tokens they can process, which affects how long your prompts and responses can be.
That makes sense. We need to keep those limits in mind when we're designing our applications.
You got it. Now let's dig a little deeper into RAG and what it means for us. One of its biggest strengths is that it addresses a weakness of those traditional generative models.
What weakness is that?
Traditional models are stuck with the data they were trained on. Their knowledge is static. But R lets them access the latest information because it can incorporate those external data sources so their responses are always timely and relevant.
So RAG is like a continuous learning system, always updating its knowledge base.
Exactly. Think about the possibilities. A customer support chatbot that uses RAG could access a company's entire knowledge base to answer questions accurately. Financial analysts could use it to analyze market trends and make investment recommendations.
Those are some really compelling examples. It sounds like RAG has the potential to be a game changer across a lot of industries.
It really does. And the key service for implementing RAG on AWS is, you guessed it, Amazon Bedrock.
Bedrock, again, it seems like this service is the real workhorse. How does it help with ARG applications?
Bedrock makes it really easy to integrate those external data sources, so building and deploying those ARG systems becomes much simpler. It's like the foundation you build your RAG applications on.
Got it. So Bedrock provides access to the models and makes it easier to integrate data for RAG. What else do we need to know to implement ARG effectively?
Vector databases are essential for RAG. These specialized databases are designed to store and query embeddings, which are like numerical representations of data points.
Embeddings, can you give me a quick refresher on those?
Embeddings capture the meaning of data, whether it's text images or audio. They allow us to compare and find similarities between different data points.
So vector databases are really important for applications that rely on understanding the meaning of data and finding similarities between different pieces of information. Does AWS offer any services for storing embeddings within these databases?
Absolutely. Several AWS services support this. Amazon OpenSearch service, a fully managed search and analytics service, has built-in support for vector search.
So it's like a search engine that understands meaning and context.
Exactly. Amazon Aurora, a cloud-native relational database, also supports this. It has the PG vector extension, which lets you store and query embeddings directly within the database.
So we can combine the power of relational databases with the flexibility of vector search.
You got it. And for those working with graph data, Amazon Neptune, a purpose-built graph database, can efficiently store and query embeddings, allowing you to leverage those graph relationships in your AI applications.
It's amazing how AWS offers these specialized services for working with embeddings in vector databases.
It's all about providing the right tools for the job. Now, we've talked a lot about customizing these foundational models, but customization can be pretty resource intensive. So let's take a moment to consider the cost implications of these different approaches.
That's a great point. Cost management is crucial for any project. Can you break it down for us?
Let's start with pre-training. That's where you build a foundation model from scratch using massive data sets. It gives you complete control, but it's also the most expensive option.
So pre-training is like building a custom house. You have complete control, but it comes with a hefty price tag.
Exactly. It requires a lot of computing power, data storage, and expertise. Then you have fine-tuning, which is where you adapt a pre-trained model to a specific task. This is more cost-effective because you're leveraging an existing model and only need to train it on a smaller data set.
So it's like renovating an existing house, more affordable than building from scratch, but you can still customize it to your liking.
Exactly. Then there's in-context learning, where you give a pre-trained model some examples to guide its behavior. This is the most affordable option because you don't need any training, but it's also the least flexible because you're limited by the model's existing capabilities.
So in-context learning is like redecorating a house. You can make some changes, but you're limited by the existing structure.
Great analogy. And finally, there's RAG, which falls somewhere in between cost-wise. It's more expensive than in-context learning, but less expensive than fine-tuning.
RAG is like adding an extension to your house. It gives you more space and functionality, but it costs more than just redecorating these. These analogies are really helpful. It's clear that there's no one-size-fits-all approach when it comes to customization.
Exactly. You need to choose the approach that strikes the right balance between cost performance and flexibility for your specific project.
Green advice. We've covered a lot of ground in Domain 3, applications of foundational models. Are you ready to move on to Domain 4, responsible AI?
Let's do it.
All right, so we've explored all the power and potential of foundational models, and now I'm ready to dive into Domain 4, responsible AI. This feels especially relevant, with all that's going on in the world today.
You're absolutely right. Responsible AI is all about making sure that the AI systems we build are fair, transparent, and accountable. They need to align with human values. It's not just about building cool tech, it's about building it ethically.
So it's about making sure AI is used for good. What are the key principles we should keep in mind?
One of the most important is fairness. We need to make sure that our AI systems aren't perpetuating existing biases and that they treat all individuals and groups fairly.
That makes sense. Bias in AI can have really serious consequences.
Yeah.
How can we ensure fairness in these systems?
It starts with being aware of the problem. We need to recognize potential bias in our data, our algorithms, and even in our decision-making processes. Then we can take steps to mitigate that bias through techniques like data debiasing, algorithmic fairness, and human oversight.
So it's a multifaceted approach that combines technical solutions with human intervention. What other principles are crucial for responsible AI?
Transparency is essential. Our AI systems need to be understandable. We should be able to grasp how they work and why they make certain decisions.
Transparency is key for building trust and accountability. What else should we consider?
Privacy is paramount. We have to protect sensitive data and ensure that our AI systems respect individual privacy. And finally, there's accountability. We need clear lines of responsibility for the development, deployment, and use of AI systems. Someone needs to be answerable if something goes wrong.
So responsible AI is an ongoing process. It requires careful consideration and implementation at every stage of development. Are there any AWS tools or services that can help us put these principles into practice?
Absolutely. AWS provides a number of services to support responsible AI development. Amazon SageMaker Clarify can help us detect and mitigate bias in our machine learning models. Amazon Augmented AI, or A2I, allows us to incorporate human review into those AI workflows, especially for decisions that are sensitive. And SageMaker model cards give us a standardized way to document our models, their intended uses, and any potential risks or limitations.
Those sound like really valuable tools for building ethical and trustworthy AI. Now let's shift gears to the final domain, Domain 5. Security, compliance, and governance for AI solutions. What are the key takeaways here?
This domain is all about protecting AI systems and the data they use from unauthorized access and making sure they comply with any relevant regulations. It really focuses on the operational side of AI security.
So as we're keeping our AI systems and data safe and secure, where do we even begin?
The first step is having strong identity and access management controls. We can use AWS Identity and Access Management, or IAM, to define who has access to our AI resources and what they can do with them. Think of IAM as the gatekeeper for your AI systems.
That's a helpful analogy. What else can we do to protect sensitive data?
Data encryption is crucial. It protects data both when it's stored and when it's being transmitted. It's like putting your data in a vault. AWS has various services for this, like Amazon S3 encryption, Amazon EBS encryption, and AWS Key Management Service, or KMS.
So AWS provides a robust set of tools for data security.
Okay.
What about understanding and organizing our data?
Data cataloging is essential. It's all about creating a centralized repository of metadata about our data assets, things like their location schema and access controls. It's like having a map of your data landscape. This helps us find data, understand where it came from, and ensure data quality.
Data quality is so important for reliable AI. How do we make sure our data is up to par?
Techniques like data validation, data profiling, and data cleansing can help us make sure our data is accurate, complete, and consistent. And of course, we need data backup and recovery procedures in place to protect against data loss. AWS services like AWS Backup and Amazon S3 versioning can provide that safety net.
Sounds like AWS has us covered on all fronts. What about securing the AI applications themselves?
That falls under security and privacy considerations. For AI systems, implementing secure coding practices is super important things, like input validation, output encoding, and secure logging help prevent common vulnerabilities. It's like building a house with a strong foundation.
What about protecting user privacy?
We should only collect the data we absolutely need, and we should de-identify that data whenever possible. Remove any personally identifiable information that isn't essential. We can use IAM to implement access controls to restrict access to sensitive data, and we need to be transparent with our users about how their data is being used.
Transparency is key for building trust. Anything else we need to keep in mind when it comes to privacy?
Of course, we have to comply with all the relevant privacy regulations like GDPR and CCPA.
Compliance is essential both legally and ethically now. What about the broader governance of these AI systems?
That's where governance and compliance for AI systems comes in. It's all about establishing frameworks and processes to manage the ethical, legal, and operational aspects of AI systems throughout their entire life cycle.
So it's about putting the right structures and policies in place to ensure that AI is used responsibly. What are some of the key things to consider?
We need to define clear roles and responsibilities for everyone involved in developing and deploying AI systems. Everyone needs to know who's in charge and what they're accountable for. We also need a process for assessing and mitigating risks, identifying and addressing any potential problems that could arise from using AI systems.
Risk management is crucial for preventing any unintended consequences. What else is important for AI governance?
Implementing monitoring and auditing procedures is essential. This ensures that our AI systems are being used as intended and that they comply with all the regulations. It's like a checks and balances system for AI. And documenting our AI governance framework and sharing it with stakeholders promotes transparency and accountability.
Transparency is so important. Does AWS offer any tools to help us with our governance and compliance efforts?
Yes, they do. AWS Config can help you assess, audit, and remediate the configurations of your AWS resources so you can be sure that your AI infrastructure meets all those security and compliance standards. It's like a compliance inspector. An Amazon inspector automatically assesses your applications for vulnerabilities and deviations from best practices. It acts like a security consultant for your AI applications.
Those sound really helpful. What other tools are there?
AWS Audit Manager helps you continuously audit AWS usage, which simplifies risk management and compliance. AWS Artifact provides a central repository for all those compliance reports, agreements, and other documentation. AWS CloudTrail logs every API call made in your AWS account, which gives you an audit trail for security analysis and compliance monitoring.
Wow, AWS really offers a comprehensive suite of tools for governance and compliance. Any final tips for navigating this complex world?
AWS Trusted Advisor provides best practice recommendations based on your specific AWS usage. It's like having a personal security advisor for your AI projects. And remember, those data governance strategies are crucial for managing AI data effectively. This includes things like managing data lifecycles, ensuring data residency monitoring and observation, enforcing policies, and documenting your framework.
That's really helpful advice. Wow, we've covered a ton of information in this deep dive. We explored all 5 domains of the AWS Certified AI Practitioner exam, from the fundamentals of AI and ML to the complexities of security, compliance, and governance.
We sure did. You've learned about key concepts, essential AWS services, responsible AI practices, and so much more. You're well on your way to mastering this material.
This has been such an insightful and empowering journey. Any final words of wisdom before we wrap things up?
Remember, the world of AI is always evolving. Continuous learning is essential to stay ahead of the curve, embrace the challenge, and never stop exploring what's possible with AI on AWS.
Thank you so much for sharing your expertise and guiding us through this incredible deep dive. Listeners, we hope you feel empowered and confident to tackle your AML goals. Until next time, keep learning and keep innovating.